when you want to do anything a little more complicated with web applications, you'll need to know more about what an HTTP request actually looks like. Curl is pretty good about showing you all of the information that you want to know about what is in your HTTP request. From least information to most, the 3 different ways that you can ask for more information are to show the headers only, to show everything including the headers, and to be verbose about pretty much everything that curl is doing. If we want to get my regular directory, then we would go to stanford.edu/tilde_samking. And then this gives you the web page that is my home directory at Stanford. If we say -I, then that will show only the headers. So you can see they responded with an HTTP 1.1. That's saying that they're using HTTP version 1.1. Some really old web servers will use HTTP 1.0. And if you only want to force curl to use an old feature set, you can also tell it to use version 1.0. 200 OK is a HTTP response code. You can look at all of these codes online, and there aren't actually that many of them. There are some that talk about errors, there are some that talk about redirection, there are some that say that everything is OK, and there are some more weird ones. Then there's a little bit more information here. The content type will be different depending on if it's sending a file or streaming a video or some other stuff. Server and the data are fairly self-explanatory. Apache is a very common open source web server. If we want both the headers and the page as a whole, we just have to change I to lowercase I. So here we get the page, and above that, the header. If that's not enough information for us, then we would say -V for verbose. Here you can see it's about to connect to stanford.edu over port 80 because that's the HTTP port. It has the IP address that it got. Then it says exactly what request it issued. So it issued a GET request for this file on this server. So whenever you issue a request, the first part of the URL, so something like stanford.edu, is the server. Everything after that is, so starting with the slash, so /tilde_samking, because I issued for a standard stanford.edu/tilde_samking. All of that is just passed to the server, and then the server can do absolutely whatever it wants with that information. The normal way to deal with it is to say that everything after the slash will basically be interpreted as a file path, and then it will look at that part on its file system relative to some www root directory, and then it will serve whatever file I asked to get, following some permissions, of course. Here we're saying that we can use HTTP version 1.1. This is your user agent, which in this case is curl, because curl is issuing the request. The user agent basically means the web browser that's issuing the request. So Internet Explorer and Mozilla Firefox and Google Chrome will all have different user agents, but different web bots will also have user agents. So the bot that Google uses to crawl the internet in order to index everything for its search also has its own user agent. And really, you can type absolutely anything you want into this user agent field. If you go to a website that filters based on user agent and says that unless you're using Firefox, then you won't be able to get the web page, then you can actually, in curl, just change what the user agent is, because it's just a string of text, and then you can get that. The host, stanford.edu, that's just the server that we're issuing the request to. Accept says what type of data we will accept as a response. So */* is saying we'll accept anything, but sometimes there will be a website that only accepts something. And you can see there's also a new line here at the end signaling the end of the GET request. Everything that starts with a triangular bracket pointing to the right, the greater than sign, is saying something that we're sending them. This is something that they're sending to us. So this is the header that they replied with. Some of this is exactly the same as you got with the -I. So these 3 lines are exactly the same, but we also get some extra information. So here we have the content length, whereas up here we didn't get the content length. The content length is basically just saying how long all of this stuff is, how many bytes it is, because otherwise it would be a little bit harder to tell how big your packet was. Everything that you see up here is customizable. This is just a packet that we are sending to the remote server, and curl lets you customize every part of this packet. If you don't want to issue a GET request, if you want to issue a POST request, then you can use -D, which is data, and it will send data as a POST. But what if you want to do something using one of the different HTTP verbs that some websites like to use? The common verbs, aside from GET and POST, are head, which is saying we're just sending a header, we're not putting anything in the body. So we're not putting anything after the end of our headers. This part is the headers, where it'll start with some word and then a colon, and that's basically saying variable :value. And all of these are well defined, and they're things that pretty much every web server will know how to deal with. Everything that's after the headers is just the body. So this is what they're actually giving you to display for your web browser. Or this is where the actual variables in the POST request go. But if you're using a head, then you're saying, I don't need anything aside from the headers. I just need to tell them some really basic information. There's a put, which is supposed to be used for putting data onto some remote server or maybe an FTP server. There's delete, which is used for deleting stuff. And then there are also some less common HTTP verbs. There's trace and connect and options, and they're all defined in the World Wide Web request for comments on HTTP version 1.1, but they're probably not something you're going to have to use that often. Before I go into showing you how to customize everything in here, first I'll just show you what a POST request looks like. If we go back to the website that we were posting stuff to earlier, post some data to it, foo equals bar, and bar equals baz, and ask for it verbosely, then you can see that we issued a POST instead of a GET like you saw above. The user agent's the same. The content length is 15, which means that that's the length of this. So foo equals bar and bar equals baz is all of the variables that we were encoding as a POST request. And you can see the content type is application/URL encoded form. And then it responded to us with whatever the web page is. So this is an Apache server also. We got a HTTP OK, and for some reason this didn't display on a new line. It gave us a HTML text page, and then it displays what we asked it to. Now let's say that I want to post a completely different header. You probably won't want to do this unless the web application that you're trying to interact with requires a specific header, or the default curl doesn't work. But if you do need to add a header, you just have to use -h. So if I say -h, and this is a capital H, and then I say foo::bar, then you can see host is code tutorial except // and foo is bar. It probably doesn't know how to respond to foo in the header, and some servers might mess up with that. But overall, you can see if you want to add a new header, it's as simple as that. Another thing about curl is that if you're sending anything big, so if you're attaching any big file, for instance, then it actually does a kind of delayed process. So it'll ask the other server if it can handle a big file, the other server will say yes, and then it will go ahead with sending the file. However, some servers don't know how to deal with that, which means you'll need to add a custom header in order to get rid of it. To demonstrate how to get rid of a particular header, I'll show you how you can get rid of the content length header, which will probably mess everything up. If we want to get rid of content length, then we just have to pass in h with content length, colon, and then nothing after it. And then you can see we issued a request here, and nowhere in this request was there any content length. As a result of that, this web page, even though it usually will display everything that you pass in, it didn't display anything there, because we said that there wasn't any content length, which it assumes means that the length is 0, so we didn't pass in any variables. That will let you change any of the headers. If you want to use a verb other than post or get, then you'll have to specify it using the -X flag, and then you just have to say something like put. And then you can see in our request, instead of a post, it's a put. All of the data that we passed in is going to be exactly the same, because the way that you pass data is just after the first new line, which means that all of the headers come up here, then there's one new line, and then there's your data, and then there's the end. And that's the same regardless of whether it's a post, or whether it's a put, or whether it's something else. And here, this website actually does know how to deal with put requests, so you can see there's foobar and barbaz. The last thing that we might want to change is our user agent. The reason that we might want to do this is because some websites filter based on user agent, and we might not like them doing that. So for instance, if we try to figure out what our IP address is, then we can curl for whatismyipaddress.com, and it will say you appear to be using an automated script, because it thinks that anything that uses curl must be an automated script. If we want to pretend to not be an automated script, then we can say -A for agent, and then pass in some string that represents a normal web browser's user agent. So if we pass in -A and then Mozilla 4.05 with a slash in between the web browser and the version, then everything will work because it thinks that we're using Firefox. And we could parse all of this mess and find out exactly what IP address it thinks we're at. Using what you know in this video, you can use curl, or alternately you can use libcurl, which has all of the same features, and a library in C, to do pretty much anything that you would need to do to interact with some web API.